In this problem, we need to replace the applied force moment system with a single force and single couple moment placed at point A. So as you can see, this member is subjected to two forces and a free couple moment. So the first thing we want to do is to represent them using Cartesian vector forms. For this first force, this is my F1. It is parallel to the YZ plane, which means that it only has Y and Z components. The direction is given by this 3, 4, 5 triangle. Therefore, it has 3 over 5 times 400 component along the negative K component, and 4 over 5 component along the Y direction, so positive J direction. Therefore, this equals to 320J, we need to write J first, and then minus 240K in the unit of pound. This force, let's call it F2. That's easier. It only has a positive X component, so that's positive 200I pound. Those are our two forces. And this free couple moment is simply about the y-axis counterclockwise. Therefore, this moment right here simply equals to positive 300 J pound-foot. And then the next step is to determine the resultant force. To determine the resultant force, we simply add all the forces together, F1 plus F2. So that's simply 200I plus 320J minus 240K in the unit of pound. And then we need to summarize the moment about point A as indicated in the problem statement. To do that, resultant moment about point A equals to the total moment caused by the individual forces about point A plus any free couple moment. So in this case, we have moment caused by force F1 using the vector formulation R1 F1 plus R2 cross F2 plus the free couple moment M right here. So we already have F1 as a Cartesian vector, F2 as a Cartesian vector. What about R1 to R2? These two are position vectors, and they need to start from point A because we're summarizing the moment about point A, and it need to end on the line of action of the force. Therefore, for R1, we're going to choose this position vector from point A to here, to this point right here. And then for R2, remember the position vector needs to start from point A and it can end anywhere along the line of action of the force. Therefore, for R2, the best choice will be from point A to this point right here. That's easier to determine. So from here, we can determine R1 to be negative 2I plus 6J in the unit of foot, and R2 simply positive 6J. So now we can start calculating our moment. So this equals to R1. We can set up a matrix for this. So we have I, J, K, negative 2, 6, 0. And then for the forces, we have 0, 320, negative 240. So that's the first one. Plus, for the second one, it's relatively easier. So we can just do a cross product of the elements, 6J cross 200I. And then don't forget our 300J. That's the couple moments here. So from the matrix, we have For I, we have 6 times negative 240 minus 0. For the j components, we have negative 2 times negative 240 minus 0. For the k, we have plus k, negative 2 times 320 minus 0. And then for the 6j cross 200i, j cross I is negative k, so that's simply negative 1200k plus 300j. And that equals to negative 1440i minus 180j. And then lastly, minus 1840k in the unit of pound-foot. So that's it. The resultant force right here, resultant moment right here.